Hi there.
Hello.
Hi, everyone. I'll look to you both for guidance on if we're expecting a few more or if you'd like us to get started.
I would start early. We can admit people as they join.
Super. All right, then. Okay, so good afternoon, everyone, and welcome to today's webinar on preparing for the Passivhaus Equivalent Standard. For those who might not know me, I'm Ellie Harji, and I'm one of the policy leads at SFHA. I'm really pleased to have you all joining us this afternoon and equally delighted to be welcoming our two speakers. Before we get started, a couple of housekeeping announcements. When you've joined the session, you would have joined with your microphone on mute, and that would just be handy to keep on mute until we get to Q&A. In terms of format, I'm shortly going to hand over to James from Collective Architecture, who will talk about preparing for the Scottish equivalent to the Passivhaus Standard. We'll then hear from Sophie Burgess from Changeworks, who will be speaking about Passivhaus benefit principles and the social housing net zero standard, and we'll then move to Q&A. So the session should last around an hour. We are recording, and we'll share a copy of this recording via our website. But just to let you know, we will stop recording following the presentation so that we can all speak freely during the Q&A. That bit won't get shared any further. So as we go through, please use the chat function to post questions, and we'll come to those at the end. And we hope that you'll be comfortable having your video enabled so that we can all see one another. But if you'd rather not, that's not a problem either. So that is everything from me, and I'm very pleased to hand over to James York from Collective Architecture. Thanks, James.
Thanks. Yeah, thank you very much, Ellie and Karen and the SFHA team for inviting me along to speak, as well as the Changeworks team for inviting me to collaborate with them on this. We've got a number of slides to share, so I'll just share screen. And go into presentation mode. So can I check what everyone has on their screens? There's a nice big picture of a building and a note saying
I think we're seeing the presentation view.
Okay.
Unfortunately.
Right. I thought this might happen. So I'll thank you for that. Okay, let me try this. So how's that? Have you got?
That looks great.
Yes. Okay. It's been a while since I've used to used to using Teams. So hello everybody. Really looking forward to today's discussion and presentation. I'm James York. I'm an architect, Passivhaus designer, retrofit designer, and net zero pathfinder for working at Collective Architecture. And yeah, today I'm going to be talking to you about our pathway for preparing for the Passivhaus equivalent and our thoughts on the current process and what lies ahead. A little bit about Collective Architecture before I get stuck into this. Collective Architecture is a 100% employee-owned architecture practice with a strong track record of design and delivery of social housing, working with housing associations and social landlords across the UK to deliver homes that are socially and, beg your pardon, that are socially and environmentally sustainable. Our work puts people at the heart of architecture. The practice is founded on the principles of promoting participation and sustainability in architecture. And we've got 54 staff in our 3 practices in Glasgow, Edinburgh, and Dundee, delivering consultancy services across the UK from Portsmouth to Peterhead. In 2020, we established Collective Energy, a consultancy service that develops and promotes the implementation of low energy, sustainable and regenerative design within the practice and the wider industry. To enable this, we've been working with the Passivhaus and Enerpit standards for over a decade, using the principles to inform our design decisions to better reduce energy demand, improve resident comfort and well-being, and mitigate fuel poverty. So why Passivhaus? The Passivhaus Standard is first and foremost a comfort standard, putting people at the center of design. We believe that the Passivhaus approach helps to deliver homes that are safe and healthy environments to live in, comfortable and affordable to heat, and helps to promote the well-being of those who live in them, enabling them to live their best lives. We see the Passivhaus methodology as a hugely beneficial tool for new builds and retrofit properties in addressing the yawning fuel poverty gap that has worsened since these stats were recorded in 2022. The Passivhaus methodology is a proven approach to reducing the performance gap that has been shown to be between 60 and sometimes upwards of 400% in new build dwellings, and that's not even getting into retrofit. We'd never accept that gap if we were buying a new car, and I've always wondered, why does the industry tolerate it for people's homes? Designing using the Passivhaus planning package to meet clearly defined criteria helps to ensure that as design performance is met at completion. SAP is a useful compliance tool. However, the focus on percentage reductions in emissions does not give as clear a picture as clearly defined metrics and targets. This is one of the key reasons why we advocate for the use of the Passivhaus approach in delivering energy efficiency. Passivhaus Standard sets out clear criteria for performance. These targets allow flexibility of design and provided the criteria are met. Sorry, I'm having a couple of technical issues here with my presentation. Bear with me. So let's try and go on to the next slide. The Passivhaus approach has enormous benefits to tenants, owners, and building managers, from reduced energy demand, carbon emissions, and running costs, to prolonged life cycle of components and services, to improved indoor environmental quality and healthier living and working environments. There's a long list of benefits that flow from adapting the Passivhaus approach, and more details can be found using the QR code. I should also thank the Passivhaus Trust for some of their images and graphics here. What defines a Passivhaus project, and what might we seek to adopt for a Passivhaus equivalent? The Passivhaus Standard sets out 3 tiers of compliance: Classic, Plus, and Premium, with escalating levels of on-site generation. The Passivhaus Low Energy Building Standard sits beneath these for buildings that find it harder to achieve compliance. Setting clear performance targets serves to significantly reduce energy demand whilst optimizing comfort and mitigating fuel poverty, while driving down emissions to meet our carbon budget. Passivhaus is an oven-ready standard that has a 30-year track record of meeting targets in the delivery of affordable homes. This makes it an ideal standard to layer into the Scottish equivalent. So what is Passivhaus in terms of the building? It sets clear targets which achieved through a fabric-first approach to reduce energy demand and meet comfort needs, which is absolutely essential. Focusing on these 5 core systems: fabric insulation, triple glazed windows, thermal bridge mitigation, building airtight, ventilating right with MVHR. Sorry, folks. But before this, reducing the form factor and optimizing the orientation to capitalize on solar gains are easy and cheap efficiency wins that, if implemented at the start of the design process, can serve to optimize the fabric efficiency and mitigate any risks for overheating. The Passivhaus approach is aligned with the REBA planner work and the key gateways for statutory approval and completion of statutory approval and completion compliance of projects. What will need to take place is a shift in approach and resourcing of building standard services to review the progress of projects and provide statutory oversight of the strict quality standards necessary for the successful delivery of low energy buildings. Scottish Government has set out a pathway for delivering legislation up to the end of this year. They've also recognised that there's a transition period required based on the level of ambition of the legislation itself. At the moment, we're waiting for the summer consultation to happen, and look forward to the process and feeding into that. So what could a Scottish equivalent to Passivhaus look like? Our view aligns broadly with the Passivhaus Trust view that ultimately the Scottish Passivhaus equivalent should ideally adopt the key criteria for Passivhaus, and that the QA process is mandated. Projects would be verified by Scottish Building Standards through the existing LABSS or Section 6 assessors. The Passivhaus planning package would be approved as a methodology alongside SAP with the conversion plugin. What would a Scottish equivalent to Passivhaus look like in terms of the transition period? This would basically mean that industry adoption and upskilling is absolutely critical, and time is needed for that. Enhanced QA processes need to be embedded and in the construction and verification process, and verifiers and certifiers need to be trained up alongside the suppliers. So in terms of the last piece of this is deemed to satisfy. And so, but I think one of the key planks that we're hoping for is that from December 2024, full Passivhaus certification would be deemed to satisfy Scottish Building Standards compliance. This would enable those who can and want to lead the way using the Passivhaus, the existing Passivhaus process to implement these projects without waiting for legislation to fully embed. As this transition takes place, the use of current tools like the PHPP and Passivhaus certification processes within the statutory framework would be beneficial for projects that are on the pipeline to be progressed in the short term and which can be used to show the way. It's expected that as a baseline, the legislation will recognize the veracity of PHPP and certification process within the statutory compliance framework. So again, this transition periods, the Passivhaus Trust have set up a notional process for how the Scottish equivalent of Passivhaus might become embedded in the industry following legislation being passed in December 2024. The definition of a clear pathway backed up by robust legislation will be critical to provide certainty on the direction of travel so that all parties in the industry can transition with confidence. And collective, we're working on a number of projects to the Passivhaus Standard and have including the Enefit Standard, Woodside Towers, 310 flats retrofitted to the Enefit Standard. We'll talk a little bit about that later. We're currently on site with Polton Street, which is an extra care and intermediate care development, and it will be the UK's first Passivhaus and immediate care building. And then Powder Hall Nursery and integrated living housing development, and which is a Passivhaus Classic project, and we're also Passivhaus consultants on Somerstown regeneration down in Portsmouth, which is a 565 dwelling mixed tenure community and commercial project to the Passivhaus Classic standard. Today, I wanted to talk about Dundas Hill, which is a Passivhaus residential project delivered for West of Scotland Housing Association, 90 units to new builds social housing, recently handed over in April of this year. The contract value for this project is in the region of 21 million. And one of the key successes of this project was the early definition of the brief at REBA Stage 2. One of the key elements of that brief was that the buildings would be fossil fuel free, and that the energy cost to heat and provide hot water within the building would be as low as gas. We early on advised the client that in order to do this, delivering the project to the certified Passivhaus Classic standard would be advisable, and they adopted it. In our view, form follows simplicity. With this project, we were able to demonstrate that with great efficacy. Orientation of the project was a really early win. We were able to get most of the properties facing south. A few of the properties are facing east-west. But the bulk of orientation of the properties which are through flats are north-south. We've got, I do apologize for this, folks. My PowerPoint is really playing up here, but I shall persevere. Form factors: simple, robust form with few indents and freestanding balconies. This makes the fabric simple and easy to design and detail and insulate. Modular construction with panelized offsite manufacturing has helped to speed up and make the delivery cost effective. And we've also integrated circularity principles using the shearing layers principle adopted to facilitate ease of assembly, disassembly, and adaptation. We've taken a fabric first approach with this project, which is broadly aligned with what we'd be looking to deliver in terms of building standards at the moment. Glazing is obviously a bit more enhanced in terms of we've used triple glazing with a U value of 0.8, but the performance of the walls, floor, and roof are not a million miles off of what you'd be doing with current building standards. Air tightness is obviously a far more onerous target, but through the simplicity of the design, through careful detailing, we've been able to reduce junction complexity and thermal bridge using thermal bridge-free ties, reduce the impact of thermal bridging on the fabric, allowing us to optimize the fabric and not have unnecessary embodied energy within the overall fabric buildups. Our MVHR system has been designed to be as optimal as possible, reducing duct length runs and achieving an efficiency of 80%. We are achieving we've not been able to achieve the 15 kilowatt-hour per meter squared space heating demand, but we're meeting compliance with the 10 watts per meter squared heat loads compliance. So alongside the air tightness targets, and we've been able to retain the fossil fuel free heating strategy ahead of this being implemented in the current standards in April of this year. Quality management has been absolutely critical through the process. We've been working very closely with the contractor to enable them to get their head around how the buildings can be built to meet the requisite standards. Deal with complexities in the design and ultimately map out a way through the evidencing and quality management process. Air tightness and thermal continuity drives a lot of the quality standards. This is a good thing. Whilst initially there's a steep learning curve, the delivery becomes more streamlined through careful quality management, supply chain engagement, sequencing, mock-ups, inspections, evidencing and sign-offs, air testing, which we had 4 tests throughout the project, and then ultimately commissioning. Good workmanship is achieved through onboarding and upskilling of trades, through QA management and a collaborative attitude. Talking about challenges leads to solutions being arrived at collectively. These measures help to facilitate smoother running of projects, which benefits contractor, client, and all engaged in the process. In terms of lessons learned from this project, the client's early commitment made by the client in terms of setting project targets has been crucial to the project being delivered to the Passivhaus Classic standard successfully. Embracing simplicity by simplifying the design and embracing repetition, we could minimize complexities, reduce errors, and enhance overall efficiency without compromising architectural quality. Early engagement and collaboration. Collaboration in our books is absolutely critical with Passivhaus projects. Collaboration should start in the design phase with input on cost, buildability, and materials. Having the contractor and specialists on board at early design stages is hugely beneficial. Site induction and toolbox talks encourage adoption of the Passivhaus ethos with all operatives on site to motivate them to take pride in their craft. Quality assurance systems, a robust design management, change control, and quality assurance system are vital to meet demanding air tightness and insulation standards. How will this Scottish Passivhaus equivalent impact housing associations? In terms of project planning, we see clear brief definition at early project stages with appropriate performance targets as being critical. The Passivhaus certification is an easy way of setting a clear set of project brief requirements. As this legislation moves towards a Passivhaus equivalent, that will become more straightforward again. Integrating the Passivhaus process into the design at the earliest possible stage is really essential. It avoids late integration can result in costly redesign. And engaging the right team is really, really important. And this goes across the project management team in-house to design consultants, your contractor, your clerk of works, tenant liaison teams, facilities management, all are key players in the successful delivery of Passivhaus or Passivhaus equivalent projects. Completion and commissioning, the quality assurance standards required for Passivhaus help to facilitate fewer defects at handover. Passivhaus Savvy Clerk of Works is a huge benefit to the whole team and the project through its delivery on site. The handover and operation is another key consideration. Clear tenant briefing on new home systems. We're introducing new things like heat pumps, new ventilation systems. All of these need to be explained to residents as they move into properties. Getting quick start guides in hard copy and digitally with accessible through QR codes, user manuals. These kind of things are really useful to help new residents and tenants optimize their lived experience in these buildings. And then staying with the property and following on with monitoring, post-occupancy evaluation and building performance evaluation to make sure we're optimizing the performance and catching any user misunderstandings of how to best live in these properties. Now, capital cost is a hugely contentious issue with the shift towards Passivhaus and the Passivhaus equivalent. It's understood that Passivhaus projects are more expensive. Industry knowledge tells us that the range of this for the capital cost of the project should realistically be somewhere between 4 to 8%, depending on the scale of the project. However, contractors do price risk into Passivhaus projects, and this is an unquantifiable sum. So it's whilst Passivhaus projects come at a higher premium, Passivhaus delivery becomes more affordable as project scale increases. This premium can be managed much like you'd manage any risk through careful project planning, engaging the right team, good design, and a collaborative approach to project delivery. Procurement is key, and appointing a contracting team that understand or are on board with the process is critical for cost-effective project delivery. Contractor risk pricing is, as I said, unquantifiable, but when inflated is usually a sure sign of inexperience. So buyer beware. Pain points around net zero and energy efficiency funding we're hyper aware of these. There's huge shortfalls between the need for funding of these projects to support their delivery and what's ultimately available. And we're acutely aware of the pressure that housing associations and social landlords are under, not only in the new build, but in the retrofit side of things. Maintenance. The maintenance regime needs to be established during the design stage and clearly thought about. MVHR filter changes and heat pump inspections require a change in approach to fit and forget systems like boilers and DMEV vent systems. Designing in ease of access to systems needing regular maintenance is essential in social housing. In terms of life cycle and life cycle costs, the QA process delivers high quality products, which also serves to prolong the material and component lifespans and means reduced life cycle costs through the building's life. We see that there are some necessary changes within the industry. This is a very short list, but it could be expanded ad nauseum. In terms of legislation, a clear pathway for change backed up by legislation to enable the industry to shift with confidence. Better access to funding to enable this change for the people like yourselves who are going to be delivering these homes is absolutely critical. and upskilling of the industry, from clients to designers to constructors, is going to be a hugely important forward shift. So building knowledge and skill to support this change in how we design and build tomorrow's homes. So lastly, we see the passive house equivalent as a key way of enabling change and how we build building homes in Scotland. We believe that in spite of the challenges for implementation, the Scottish equivalent will be hugely beneficial to all parties engaged in delivering new homes, setting clear targets and standards, defining quality at all project work stages, promoting longevity of new and existing housing assets, and mitigating fuel poverty and improving livelihoods, as well as setting homes on a net zero carbon trajectory. Delivery of passive house is doable, especially at scale. The industry is already transitioning towards passive house in line with changing building standards, and with clear legislation and the right support across all sectors of the industry, this important shift can happen, in our view. Thank you, everybody. And there'll be a bit of further information for those interested attached with our presentation.
Thank you, James. That's great. So we've heard from James, so I'm now going to pass over to Sophie from Changeworks.
Great, thanks very much for the introduction, and thanks all for coming along. I am just going to share my slides and share my screen and get started. Is that okay for everyone? Great, brilliant. So yeah, as part of this talk, I thought I would also, we would introduce the idea of benefit principles and talk about other legislation that's expected with retrofit, which is the social housing net zero standard. So just as a bit of a background to Changeworks, so Changeworks has over 35 years experience in delivering high impact solutions to low carbon living. So our main strategy is to drive the decarbonisation of homes in Scotland. As we're probably all aware, that Scotland has some of the least energy efficient homes in Europe. So essentially, with our aim being decarbonising homes, we're kind of tackling one of the key issues of the climate emergency. So as a bit of an introduction to myself, I work with the Net Zero Pathways team. I'm an architect and also a passive house designer. And essentially the Net Zero Pathways team works directly with social landlords, and we help to achieve standards and go beyond towards net zero. We do this by looking into housing associations or social landlords specific stock, and helping you understand what net zero means for in the stock specific solutions, and we provide kind of tailored innovative solutions, and this looks at this kind of wide range of different areas, so everything in terms of baseline, understanding what's in the stock, to developing strategy, to looking at behavioural change, and doing modelling with Passive House to look at different solutions. And so essentially we can kind of help at every step of these different journeys. So in terms of, this is just a bit of an overview that I'll talk about in the next 10 or 15 minutes. So I'll just cover the kind of background to net zero with retrofit and existing properties, talk a bit about the interaction between NFIT and the social housing net zero standard, or also I might refer to it as SHNZ sometimes as well, with all these acronyms, and then also start to think about how understanding the principles of NFIT can work towards achieving the net zero standard, and what this means in terms of strategy. So in terms of the scale, the level and scale needed for retrofit, so research has shown that to achieve a just transition towards net zero, a 70% reduction in energy use is required from our properties. And the diagram on the right is from some LETI guidance, essentially showing the reduction that's needed to lower the kind of energy spent on heating our homes. This requires whole house retrofit at scale. So treating the whole of the property rather than thinking about individual measures. Also, to achieve this, robust quality assurance is needed. So this ensures that projects achieve these predicted or modeled results, and it's not just kept in the model, that it's actually the savings are quantified in real life. And also to note that greater reductions in energy consumption to achieve net zero are needed than current standards. However, depending on the social housing net zero standard, this may address this current discrepancy. So the social housing net zero standard is the proposed replacement for EIS2. It's going to be introduced in 2025 at the earliest. So right now the consultation document is out, and I believe the deadline for consultations has passed, and they're going to look at all of those responses, including, I think, Changeworks. I know that SFHA has also put forward a response. But essentially the document supports a fabric first approach, and it also aligns with fuel poverty targets that the Scottish Government has set. So its main areas of focus are heat demand reduction, so reducing the amount of energy used to heat the property, and they refer to this with the fabric efficiency rating, which is measured in kilowatt hours per meter squared per year, but basically the amount of energy spent per area of the property over the course of the year. Another focus is the replacement of polluting heating systems. Also, they mention ventilation, which I think is sometimes gets forgotten, but it's ensuring good air quality. And it's making sure that when air tightness is increased, there's a ventilation strategy so that the health of people in the building is maintained. As an benefit overview, so it's the Passivhaus retrofit standards, and it aligns very closely with the Passivhaus new build standards, but it's adjusted to reflect the limitations with retrofit. So essentially you can't always achieve the same high standards when you have an existing building. There's two different methods. One is based on insulating components like the walls or roof to a certain level. Another one is based on just the kind of space, the heating demand figure for the property. But with all of them, air tightness testing is required, mechanical ventilation with heat recovery, and also limited energy use. And as with the Passivhaus equivalent, it's thinking about comfort and health in mind. So in terms of thinking about benefit and thinking where this fits into the proposed commissioner's legislation, there are some areas of lap over. So essentially, it's good to have an understanding of benefit principles, because they can help you achieve or think about the key focus in the kind of upcoming legislation. So as shown here, the key focuses of the net zero standard are heat reduction demand, replacement of heating systems and ventilation, and several of the benefit principles feed into these. So almost thinking about these principles can help achieve the legislation, and having an understanding of them, even if you're not after certification of benefit. Sometimes using the benefit standard can really help with a deeper understanding of what the property is actually wanting to do. So just to note also, there are some areas of net zero that aren't necessarily within the net zero standard, or there are some aspects to think about that are beyond the kind of criteria. So obviously, longevity is something to think about. That Enefit and Passivhaus, they are put emphasis on the longevity of components and the thinking about life cycle costs. So making sure that when you place components within them, that you're not replacing them constantly, or having materials that are able to kind of hold up and have a long lifespan. Also thinking about maintenance, so thinking about maintenance as almost an energy efficient measure. So as James had mentioned, building in maintenance to different services to essentially ensure that you get the most out of them and increase the lifespan of these components. And that helps with the net zero aspect in terms of you're not having to buy new pieces of equipment, but also helps in terms of costs overall. So regularly having maintenance means you don't have to kind of replace a system wholesale. Also thinking about embodied energy. So as mentioned, the replacement services, but also this is about material selection. So natural materials, some natural materials may have less energy put into them when they're made. And it's also thinking about if you can reuse or recycle materials at the end of life. So these are just some kind of net zero things to keep in mind, even if they're not necessarily within the legislation. So in terms of how to integrate Enefit principles into strategy for housing associations, so to achieve these high levels of energy efficiency and also kind of continue with projects and maintenance before the net zero standard is actually confirmed, one approach that can be useful is a phased project approach. So I'll run through an example of a project example of stage installations. Also, just to mention that past 2035 is one approach to ensure a joined up approach to staging projects. So essentially it's taking the planned overall project and then breaking it up, and so you're not installing all the measures at once. And then also one other way to kind of integrate the Enefit principles into strategy is looking at existing properties and analysing them with the Passivhaus planning package. So this models measures in a different way to SAP, and some kind of researchers suggest it has more accuracy to real life. So I'll talk through one project that we've been working on and with the Glen Housing Association. So the project aims for this project were that we were going to deliver high-level net zero strategy development, look at best practice results and best practice approaches rather, and then also thinking about affordable bills to tenants. So we also did an occupant survey on this project, which I think was interesting, again, to think about comfort and health within the project. So the results came back that the majority of respondents felt that their energy bills were unaffordable or very unaffordable, and majority had stress or anxiety about this. There was also health impacts associated with homes. So the homes being too cold or damp, and there are obviously kind of health implications with this. So we found this doing the survey quite good to, again, put into context the work we were doing. And we looked at performance monitoring, which essentially showed that lots of these properties were very cold, were damp, and it did have issues. So this is just showing that the humidity is outside the normal range. And also use thermography to look at the kind of cold bridges and cold junctions in the properties. We proposed a range of scenarios, and these were all modelled using PHPP. Yeah, this kind of came out with a range of results in terms of what the energy was needed to heat these homes, and also the fuel bills for tenants. From this, we had several fabric recommendations. So some of these I've touched on already. So it's thinking about the interaction between measures. We wanted to ensure there was quality assurance going forward. We wanted to ensure that there was improved air tightness, and also thinking about ventilation at the same time of these upgrade of fabric measures. And in terms of ventilation, we wanted to look at continuous ventilation. So in terms of the medium-term plan, a phase approach was taken by the Housing Association. So the recommendation for the first step was improving the ventilation system and replacing the windows, which improves the air tightness. From our understanding of ENERFIT principles, we're able to look at this interaction between the airtight building and the mechanical ventilation. It was introducing triple glazing, which helps with comfort, and it also reduces the amount of condensation on the windows, so they can also help with the longevity of the windows. And then also one of the main aims was reducing that heat demand and the energy used. So from that, a project is on site right now. So some of the measures currently being installed is the replacement of windows and doors, which is triple glazing with a specialist ceiling tape, and the installation of decentralized mechanical extract ventilation. So it's the continuous at a low level, and then can ramp up when it detects there's high humidity. And there's also kind of a maximum noise specified. So again, thinking about comfort. So I'll hand over to James to talk about one of the Collective Energies projects as well.
So James, I think you might just be on mute there. We all do it.
So shall I just quickly screen share once more? Yeah, sorry, beg your pardon. I'm having a little technical issue here. Sophie, would you mind screen sharing? Sorry, something odd has just happened. Yeah, very out of practice with using Zoom, and I've shrunk everybody down, and I can't seem to get the thing back working. So, is that okay, Sophie? Do you mind?
I'm not sure if I have the slides with
right,
me.
okay.
So apologies.
Okay. So let me work this out. There we go. I've done it again, folks.
That's not a problem, James. Take a couple of minutes to just try and find them, and I'll let you know when we can see.
Thank you.
What I will say is to everyone on the call, this is your chance to think of some questions for James and Sophie based on what we've heard so far. So use this time wisely.
Okay. I'm hoping I've also managed to sort out my slides jumping around. So thank you for bearing with me through that. I had to go digging around in my PowerPoint settings there. So I think I can share this now. Okay, can you see three lovely
That's
looking
great. That
retrofitted
looks
tower
great.
blocks? Fab. Okay. So yeah, very, very quickly, because we want to get on to questions. Back in 2012, Collective Architecture were appointed by Queen's Cross Housing Association to carry out an appraisal of their housing stock specific to the three Woodside Towers. These are three 22-story tower blocks, 310 homes, all pretty much all of them occupied, and a thriving community embedded within these tower blocks. Through a consultation process, initially there was talk of potentially taking these multis down, but through the consultation process, it was identified that the residents like living in the blocks and would much rather they were improved than demolished. At the time, we needed to comply with EIS 1 in its iteration, and there was funding available to within the marketplace for pursuing the development of the design along the lines of the NFIT standard, and so we progressed with that. Queen's Cross Housing Association got behind the NFIT process, and the design was developed accordingly. The construction of the building, these are reinforced concrete cross-wall construction with precast concrete cladding panels. There was no insulation in the building whatsoever. So critical to the successful reduction in energy demand was improving the form factor of the building. These are massive slab blocks. The form factor was already great, but I'll talk a little bit more about how we improved it further. Optimized the insulation through a fabric first approach. We were able to get the insulation thicknesses down to 160 mil on the main facade and 180 mil on the exposed gables. We were able to treat thermal bridges principally through an external wall insulation approach. The orientation of the buildings was already pretty good, so we were able to capitalize on the solar gains, and ultimately through the fabric improvements, we were improving the air tightness. We needed to get that down to 1 air change per hour, or 1 meters cubed per hour per meter squared. And then ultimately, we needed to ventilate the buildings right, so introducing MBHR systems. The pre-retrofit space heating demand was 120 kilowatt hours per meter squared per year, and the NFIT standard is to get that down to 25, which is what we were targeting. The form factor of the building, as I said, was already pretty good, almost, I dare say, very good. But there were a lot of inset balconies, and there were a lot of projecting balconies, which were presenting a huge amount of thermal bridging. And so one of the early strategies that we developed was to take make the inset balconies internal sun rooms, basically, and to maintain the continuity of the thermal envelope down the outer face of the building. We also turned the projecting balconies into oriels or winter gardens. Those were cold structures, but through careful thermal bridge design, we were able to basically to get those to work and effectively maintain a much more efficient thermal line for the building. So that contributed to a 20% reduction in the form factor, and this is what I was talking about earlier in my presentation. These critical design moves at early stages in the project can save huge amounts of energy. That 20% we'd have had to make up for with additional insulation, higher spec, more embodied energy going into that. So through careful rationalization of the design, you can make some really powerful and significant energy efficiency and carbon efficiency moves with these projects. So one of the other huge challenges with this project was all the residents were going to stay in place during the retrofit. There was some minor decant through the project, but luckily we were able to apply external wall insulation with these tower blocks. We're not able to do it on all tower blocks. We're currently working on a set of category A listed tower blocks here in Leith and in Edinburgh. But with these, we were able to take an EWI approach. That meant that all works were undertaken with tenants staying in their homes. Decants were arranged for more disruptive works, that specifically around changes to the heating system and the ventilation systems. But the sequencing of activities, working with the residents through carefully considered tenant liaison, both the contractor and the client team especially had dedicated tenant liaison officers for the duration of this project. That was a key strand to the success of this project. So certainly Passivhaus standard retrofit is deliverable, particularly at scale, and we were able to work with our client. We didn't go down the full certification process that got kiboshed at tender stage, but we continued to work with the client and the contractor to retain those core principles of the NFIT process through the delivery of the project, which meant things like mechanical ventilation with heat recovery were retained. Air tightness, which we were able to test on a few properties, was down at 1. Yeah, the thermal bridge free design element of the retrofit was delivered on. So that's just a very, very rapid fire snapshot. I'll stop sharing.
Thank you, James. That was great. So, conscious of time,